All right, guys, I wanted to go into more specific options for you to figure out fueling before workouts, during workouts, and after workouts. So we'll tap into how you work on improving performance by strategic carb timing. And what does that look like? What are some options? So we've got some of my favorites are VESPA, S Fuels, using Ketone IQ. There are bars that I get from Laird Superfoods for bike rides. There are different options you can put in your coffee for pre-workout. And then there's fuel during workout that depends on the intensity, what you want to do. So we want to match our fueling with our workout intensity. And ideally test your metabolism at rest and during exercise with what I do, Pinoe metabolic testing cart. That's a mask you're wearing, and we're analyzing the air that you breathe in, your oxygen, and the air going out, your carbon dioxide. The ratio of those two is called your RER, respiratory exchange ratio, or RQ, respiratory quotient. And if you've been listening to all my videos, RER at 0.7 means that you are burning almost 100% fat. And if you're 1.0, the other end, you're burning carbohydrates. If you're doing, say, a blend of 50-50 fuel, fat, and carbohydrate, that number is 0.85. So if we do a metabolism test at rest, we can identify what is your resting metabolism, what fuel source are you primarily burning at rest, and if we see some metabolic health dysfunction, that you're burning carbohydrates at rest, we know to dive in a little deeper to look at your other markers as a blood chemistry panel, looking at your insulin levels, your full thyroid panel, if your metabolism's slower than it should be, as well as looking at what's causing your metabolism slow down with other functional lab tests, mycotoxin tests, a GI test, and a Dutch test. So we want to investigate what's really going on if you want more of a personalized approach instead of just guessing how you should fuel, how you should train and perform your best every day, so you can age well, so we can improve how we age. And looking at ourselves now, 40, 50 something year old, looking at how you're going to be showing up to life when you're 70, 80, 90 years old is really important. So don't wait until you're broken. Don't wait until you have metabolic chaos. So I today have Peter Defty coming on the show again. We've talked many times, so check back our other videos on VESPA and optimal fat metabolism. Let's do a little recap with Peter today. Okay, I've got Peter Defty coming back on the show for, I don't know, your 10th time, but we still keep having to hammer this information in. So we're going to talk optimal fat metabolism and how to use fueling to improve performance and improve fat oxidation. And I've been diving down the rabbit holes, and I thought Peter would be great to talk to about OFM and VESPA, because we've been talking about what should I take to improve my fat oxidation, and I know VESPA's kind of started from all that. So Peter, top of
Right,
your
right,
mind.
right. Well, yeah. Uh, Great to be back talking, having a conversation with you and recording it because I have these great conversations with people like you, and a lot of times they're just private conversations. And it's the
Yes,
kind of information people need to get out there, right?
for sure. I've been going down
All
this
right.
rabbit hole, and I think it's important to talk about.
Well, and it's the thing is when you are metabolically fit and you've built the metabolic capacity, which is something we'll talk about, it's not a keto diet. People don't realize that. So because they don't understand the link between optimal fat metabolism and optimal metabolic state, which is really about building your metabolic capacity, because you hear a lot of talk about metabolic efficiency, metabolic flexibility. If you want to be optimally healthy and perform the best, you've got to build your metabolic capacity. What that means, having really great cell wall structure and a
Whoop, I lost
really
here. We can't
strong,
hear you.
robust
Oh,
set
there
of
you are.
mitochondria.
Yeah, so say that again. It just went out for a second. So what is the
Okay.
definition
Okay.
of
So
being
when it really comes down to in terms of capacity, which is done on a fat-based metabolism. Because, and so, and when we talk about that, we're talking about it on a cellular level. Everything I look at starts at a cellular mitochondrial level. And how do you
Yes.
tweak the cells and the mitochondria, not the muscles, to perform optimally? It's getting the cell walls to where all those elements go in and out flawlessly without a lot of oxidative stress. It's also about the mitochondria, building a set of really robust mitochondria so you can have that fat oxidation that we're seeing, right? And
Yeah. So you
here's
said, hold on though, just fat oxidation, mitochondria, oxidative stress. So three big terms that we need to, it always, I think, comes back to the mitochondria. And then I've talked a lot about oxidative stress. So continue on.
okay.
Do you
So,
need glasses? Are
but
you trying to read the notes?
I'm vain and I'm squinting a little here, but I'm pulling up some stuff to share just in case, just so we can give some credence to what we're doing, right?
Yeah.
So let's back up here and shift from fat to glucose.
Yes.
And the reason glucose is studied for sports performance is it's the last thing, right? It's the last thing. You add the carbs in the last, you get the performance. Well, that's because carbs, sugar, which is all, it all ends up as glucose, right?
Yeah.
That's not even debated in basic physiology. Okay. Glucose is your fight or flight fuel from an evolutionary perspective. And it's also, from an evolutionary perspective, a bridge, what I call a bridge fuel, which means it bridges the gap in energy demand. So when you go from being in a sedentary state to starting to warm up for your workout, you're going from two different energy states. Well, it takes a while for all those internal metabolic pathways to ramp up to deliver fat, ketones, and glucose from fat. So your blood glucose and your glycogen bridge that gap. So it's from my perspective, which I look at from an evolutionary biology perspective, is that's what glucose function as. It's just an energy source. It doesn't do all the magical things that fat does. Fat is a carrier and a part of cholesterol. This is what everything your body is made out of is through a fat metabolic process. So, and of course, the mitochondria are your powerhouses. That's the energy manufacturing. There's more going on there. There's a whole lot more going on we won't go into, but people hear that term and it's really important. And excess glucose use as an energy source actually degrades your mitochondria. Okay. Because there's a lot of oxidative stress, lactate load, and there's a thing called glycation, which is also termed advanced glycated end products, which the acronym is AGES. Which because and the joke is the acronym is accurate because all those things that I just talked about, the oxidative stress, the lactate load, and the glycation that goes along with it, actually accelerate your aging process, right? Whereas fat oxidation actually slows that process to a crawl. And then with a lot of people who've had metabolic derangement or something, it actually can reverse their aging process. So I hope I'm kind of like clarifying. So you've got these, you've got these, the principal energy substrates are glucose, ketones, and beta oxidation. And beta oxidation is what produces ketones. And oddly enough, when you're hormonally hardwired right as a fat burner, beta oxidation in the liver will actually also convert liver fat into glucose to meet the metabolic need.
When we need it.
When they need it. Right, right. The body, I think, to not lose people, because we're going down those rabbit holes like we always do, people need to think of their body when it's in that native physiological metabolic state. It's amazing. It's self-sufficient, not forever, but in terms of that evolutionary lens of hunter-gatherer, it's like I say, primitive man didn't get up in the morning, have a bowl of oatmeal, grab a couple of gels and a spear and go out hunting. Usually had to get up in the morning, and if it was time to go out and get something to eat after a couple of days of fasting, um, he had to go out and perform as if his life depended on it, on very little. And, oddly enough, those pressures that shaped us or created us, um, made us, you know, very robust and able to perform at a very high level. So that's what people need to know is like your body, when it's working properly, is amazing. But these are like all complex science, but you just have to know it works in the real world once you get it going. By the way, you look great. You look metabolically fit
Trying.
for a woman of a
I
certain age, right?
Yeah, I'm trying to get my goal. That's why I keep doing on this podcast. How we need to change how we train and how we fuel as we age, and not trying to do what we did when we were 30 years old. I'm going to the gym 5 days a week and lifting weights instead of doing 3 hours of cardio every day. Just spend more time
Well,
getting
and
stronger.
you need to do all modalities from what I've looked at it. And
Yes,
part of the reason that the resistance training works so well for you is, guess why?
I'm a
You
female.
have a huge you have a huge no, you have a huge aerobic base from years of
Yeah.
endurance training. And see, resistance training works, but you got to build your aerobic capacity to build your metabolic capacity. If you
Hmm.
don't do that, you have to build your cardiovasculature to be able to get the oxygen out, the CO2, the oxygen in, the CO2 out, and keep those mitochondria in beta oxidation as much as possible, even in resistance work, so you're not having the degradation. So if you're doing just resistance work without building that aerobic fat burning base, you're going to build what I call a lot of white meat. This is why a lot of young males, of course, they got testosterone helping them out, but they get these muscle hypertrophy that makes them big and they look strong and they're toned, blah blah blah. But do they have? But I mean, if you have to have them run a mile or two or a 5K, can't by the time they do something like that, anybody who's fit could just kick them to the ground
Yeah. Well, I'm gonna say I
because
do cardio after I do weights, and I do my hill. I do shorter workouts. I do more short intervals, a few days a week in hills, and I bike and swim. But I
yeah.
think so. That kind of leads into the main questions here. We have a lot of information out there on social media and major podcasts that people are, I think, getting confused of female versus male, but also in general for athletes that are aging, how best to fuel and train so they can perform their best day to day, but also I hope everyone's focused on their future self. So, talking about that base foundation training, we hear the zone two. Granted, I keep talking about this because I do metabolism testing. Zone two, if we test you, is where you're burning your peak fat. To the top of zone two is where your metabolic crossover, where the carb usage goes up, fat goes down. First question for you to hear your opinion on anything that we need to do to improve fat oxidation if we can test ideally, but how much time should we spend in zone two? And with the mindset, I want to improve my fat loss as I age, fat oxidation rates.
Okay, so I'm going to try and keep this real easy and simple and relatable to the audience. So I love Pareto's law, which is the 80-20 rule.
Mm-hmm.
Okay, so 80% of the time you should be in zone 2 or below. Um, and 20% of the time is a mix of a high intensity type training, sustained high level like tempo if you're a runner or a cyclist. Um, or if you're a CrossFitter, you want to be doing high level, high aerobic level stuff for sustained periods. That's a tempo type of workout. And then you do the long, long cardio because that's when you're looking through it from an evolutionary lens, that's what we did. Humans, I mean, part of the reason we migrated out, say we're going to assume the beginnings of humans was in Central Africa, right? This is for argument. The reason we migrated all over the world the way we did is A, we were bipedal, and B, when we traded a big gut for a big brain and started eating animals, it was real simple. you feasted and fasted, which meant you followed the great ruminant herds. And as populations of humans grew, they pushed out to different herds. And, that's why you have the Maasai and their Hudsu hunter-gatherers follow, the Hudsu follow the ruminant herds in Africa. And then you have the Laplanders up in, Finland who have reindeer, or in Mongolia. It's like those ruminant herds provided a stable food source. Okay. So I've seen this in all our data, especially with somebody like Jeff Browning, who's an ultra runner at 53 and still winning races and setting records. He just set an FKT for the Colorado Trail. Anyway, he does a lot of resistance training, strength training, as well as running. Okay, and he's like the model for what we do, because he's doing it. It's his day job. He coaches. He's doing everything I wish I was doing, but I'm too lazy. I'm too busy to do. So he's doing everything right. And at 53, he's still at the top of his sport, which is just unheard of, right? Okay, but it's that big aerobic it's that big aerobic fat burning base. Okay, and
Yeah,
it's
key.
that combination of getting fat adapted. That's your foundational physiology, right? And then building it with this mix of 80-20. A lot of stuff is 80-20 at 80% at zone 2 or below. And then the combination, right? The combination of all these things. Now, that combination, that 20%, is critical because it moves that zone 1 and 2 up. Now, your heart rate doesn't change, but say your pace, your strength, your ability to do work increases. And it's that adaptive stress of interval training, resistance training, tempo training. And then you bring it into the long, slow stuff, and that aerobic and metabolic capacity expands.
The training more time in zone 2, plus I'll add that when I do metabolism testing on people, you can identify if they really need to spend more zone 2 time than others because they're really low, and we want to improve that. And that, you're saying, is more that building that big base up first, or if you're spending too much time at the high end, you need to build that base.
Well, start by getting that fundamental shift in your metabolic profile, which means you become more of a fat burner than a glucose burner, because there's a lot of endurance athletes out there who are literally addicted to their glucose, right? They have energy swings throughout their workday. They can't go do a workout without taking in external calories. I mean, every athlete who's metabolically fit should be able to go out and do a 2-hour training session and not have to take in any significant external calories during the session. Just stay hydrated and go. For extended stuff, yeah, some calories work, but not this stuff where you tape 20 gels to your crossbar on your bike for a Ironman. So yeah, you got to build that aerobic, but you build it with just getting going, pushing it out. But you also need you need the hit, you need the tempo, you need the resistance to give that adaptive stress to build the aerobic capacity too. It's just, those are small micro doses along the way, and then you push it out with that zone 2 or less.
And that's related to our mitochondria to improve fat oxidation. You want to
touch correct. That on? And then you shift. I'm going to see if I can pull it up. Let me squint around here a little bit. But,
like me.
That's related to building up the mitochondria to become a bigger fat burner. But you need a lot of mitochondria. There's 2 things you need to be a big fat burner. You need a lot of mitochondria, and you need to optimize your cardiovasculature. That's your heart, your veins, your capillaries, your arteries, all those things. You have to get rid of the inflammation caused by excess glucose and excess insulin, right? Because that constricts the cardiovasculature, because you need, in order to build mitochondria, in order to fat burn, you need lots of oxygen in, get the CO2 out, because it takes twice per ATP, it takes twice the oxygen on beta oxidation it does for ketosis or glycolysis.
to get fat,
Okay.
to oxidize
And
fat.
that's one of the
It's ideal.
reasons why a lot of the quote unquote experts who push glucose metabolism say for high level work, oxygen becomes the limiting factor and why you can't burn fat for higher level stuff. Well, if your cardiovasculature is all inflamed, well, those pipes that are delivering blood in and out of and the cells, um, they're going to they're going to be constricted. So how much flow can you get in and out? Well, it's going to by default, that restricted flow is going to make you burn more sugar because
Yeah.
of the fact that you need less oxygen to create ATP. And this is really clear in things like neurodegenerative diseases and all kinds of stuff. A lot of the basic research now is showing that as we quote unquote age in the normal in what is called the normal healthy fashion, your ability to have this robust cardiovasculature degrades, and it's really important to maintain that.
You need to start wearing reader glasses. I finally had to do it.
I know. I'm gonna just
You're
pull
like me.
up.
I'm not going to wear them. I won't wear them during the day, but when I'm on the computer, I have to wear my blue blocker readers. So while you're
Right.
looking at that, I think it's important to understand the mitochondria, as you're talking about, important part of being how we improve our fat oxidation rates through our training and fueling. And I want to get to down to the big question we'll get to is to how do I activate more fat burning when I'm training? Do I need to have 40, 50 grams of carbohydrates pre-workout, especially as a female, because they're saying it'll take longer to burn fat. So I need to have those strategic carbohydrates, but the recommendations are 30 to 50 grams. And I'm
Oh,
curious, like maybe 15
it's
grams, or
crazy.
sometimes
So
they say,
okay, so let's take a break here, and I want to challenge the audience. This is a big challenge because and if you get it, I mean, the few of you guys that'll get it out there will think, oh, and then it's going to be a little scary because we're going to have to you got to rethink everything.
yeah.
So this is one of the things I've thought about for years, and I keep testing it to find out if I'm wrong. I want to prove myself wrong.
Mm-hmm.
But what if most of the assumptions that we're making for health and performance are based on a flawed foundation? Meaning, like when you talk about cholesterol for heart disease, or you talk about what Stacy Sims is saying, or somebody else was saying the other day, I was reading something. Well, if you base it on the physiology of the modern post-industrial human,
Yes.
that physiology is not the physiology we evolved to have. And
Correct.
that's the problem is the model is flawed. Now, when people like you or Jeff Browning or any fat adapted athlete, they say, oh, I'm a freak, I'm an outlier, blah, blah, blah. And people point to him as like, oh, Jeff Browning's Jeff Browning had the same problems in 2015, as any elite athlete with GI issues, inflammation, right? It's just the model of what all these people are basing it on is flawed. Now that's why their work suggests there's like Stacy Sims is a PhD. She studies science. Okay.
Mm.
If you make the assumptions based on the modern human, there's this is the fly in the ointment because what is considered normal and healthy as an athlete today is not the model that humans evolved to over millenniums, millions of years, however you want to interpret it, from full-blown Richard Dawkins evolutionary biology to full-blown creationism, it all makes sense. We evolved to burn fat as our aerobic energy source. Why would we store lots of fat and limited glycogen?
Mm-hmm.
Right. And
Yeah.
and to a point, our glycogen stores, that 2 hours of glycogen we have stored that everybody tells you about and tells you need to feed, that's a robust store of glycogen for fight or flight and bridge fuel if you use it as that, right?
Mm.
If it's
All the
used
time.
as a fight or flight fuel and a bridge fuel, we got plenty of glycogen,
Mm-hmm.
right?
We'll make more when it's empty.
And we'll make more. We'll make more. As the faster study showed, we'll replenish that glycogen from liver fat if we need to. Okay.
Mm-hmm.
So that's the fly in the ointment. And it's very hard to shift people. I've been noodling on this in terms of the human condition. It's hard for a lot of people with titles to say, I was wrong. And that's where Tim Noakes should get a lot of credit because he was
Yeah.
willing to say, I was wrong about all this. I made a big mistake. And it's very hard for people with titles and a published literature say they're wrong because it potentially could ruin their career, their revenue stream. Um,
Mm-hmm.
and just, it's kind of humbling, right? But we live in a world where we've got all these influencers and experts, and they're all like talking authoritatively. But that's a big part of the problem is nobody's curious and nobody's having a conversation and thinking about this thing from a different perspective. So it's real key for people to understand the modern human physiology. Like when you look at cardiovascular disease and this whole thing with high cholesterol, I'll bet you have high cholesterol.
I do. I've done
Okay.
videos on it. Like
Yes,
I
right. You're a
so
lean
what?
mass hyper responder.
Mm-hmm.
It's like you're trafficking cholesterol because you're metabolizing cholesterol. That's fat metabolism, right? You're not your high your high cholesterol is because it's being used as an energy in a building source.
Mm-hmm.
It's a big dump truck delivering goods to the cells. The person who's a glucose junkie, it's backing up like a traffic jam and causing accidents and inflammation, all that. It's it's that modern, it's that modern construct that we humans think we're so ingenuous about, but it always comes with unintended consequences.
Yeah,
And so
for sure.
the modern science of sports physiology, metabolism, health, etc., everybody's looking at it over the last 200 years because that's when science really kind of blossomed.
Mm-hmm.
And so it's based on all that data, and that's what they point to prove that they're right. That's how. And I listened to a talk yesterday with a guy, and he was saying, yeah, too much of science right now is not done with creativity and discussion. It's just looking at the database and the published papers and not thinking outside of this echo chamber that everybody's in.
Mm-hmm.
So, there's no doubt that glucose works for performance. Okay. But this idea that you need to smash, like you were saying earlier, 50, 60, 90, 120 grams an hour, and this is what the pros are doing, and the inference is you need to be doing it too. It's sheer madness because yes, they can perform for that race, but what's going on metabolically? It's like you call it metabolic havoc or chaos or something like
Metabolic
that, right?
chaos. Mm-hmm.
Right. I mean, it's literally a shitstorm of oxidative stress, lactate, glycation, because the body's trying to do everything it can to get rid of that glucose in your system before it kills you.
Mm-hmm. So it really depends on personalizing your fueling and training program based on how well you metabolize fat and how healthy you are at a cellular level, looking at your mitochondria function. And as I do the resting metabolism testing, are you burning mostly fat at rest, lying there? And then during exercise at various intensities. But the question I keep contemplating, like, I don't know if that's right. Trying to understand the recommendations that I understand not doing fasted exercise, but if we are able to wake up and work out, if we're doing a zone 1-2 workout, we're burning fat. Do we cause more stress in our body by not having any fuel on board? So when we should add in fuel pre-workout, and then compare that if we're doing a zone 5, zone 1 interval sprint interval training. And so I think it depends on the fueling. So we talk about how to fuel before a workout depends on the intensity, but doesn't it also depend on how metabolically healthy you are and how well you do at burning fat at rest. So you wake up and you should be burning fat, but
Well, here's what we've seen. Yes. Resting metabolic rate. I'm trying to find that picture right now. Again, I've got a great picture of one of our athletes resting metabolic rates, and I probably when you started talking about that. Anyway, that's a moving target. You want to improve. First of all, let's share a screen here. This is from the FASTER study. Can I share? Have you got the?
advanced sharing
All
when
right, I'm gonna
all
screw it.
participants
I'm gonna
here.
put share screen. Here we go.
You can share.
All right, so I'm gonna share this screen.
Okay.
This is from the FASTER study, and so what we're seeing here is how this is the high carb HCD stands for high carb diet cohort of runners. This is the low carb diet, and 10 out of the 12 were OFM athletes. They weren't keto. Anyway, you see how their crossover is right aligned with the George Brooks crossover at 65% of your VO2 max. You cross over from burning fat to glucose. But here's what happens. With the low carb diet, you're actually pushing it into the 80 percentile before your fat oxidation goes down. And we see, and I'll show you data that we have, some pilot data we have that pushes it even further. So the goal would be to build your, get fat adapted and then build your capacities to where you can not only increase the intensity level, because 75, 80%, that's the sweet spot for Ironman triathlon, right?
Yeah.
When you're racing.
Yes.
Okay, so all of a sudden you got this data where you're going right at your sweet spot, burning fat. You've not pulled over but see, it's not just shifting the intensity level to higher work, like zone 3 work. The amount of fat you burn doubles or more. And so
where
that
you
changes.
improve.
That has huge implications, because when you're burning sugar, a lot of sugar, we go back to what I was saying. You got the oxidative stress, free radicals, reactive oxygen species. You got the lactate load, because if you burn too much sugar, you create excess lactate. Your heart, your liver, your kidneys can only absorb so much lactate, so the lactate starts to build up. Some people know this as lactic acid, but it's lactate, which is a buffered version of lactic acid. Okay, it's a byproduct of burning sugar. And then you have that glycation thing, which is when a glucose molecule attaches to a protein, and it can be hemoglobin, which is what your hemoglobin A1C is, or it can be other molecules in your bloodstream. And what happens is having that glucose attached to it makes it very prone to oxidative stress, which not only creates the free radicals in your bloodstream that are going off and damaging your cardiovasculature, but it's also using up oxygen you could use for beta oxidation in your muscles. So it's a very inefficient thing. So to answer your question, what we want to do is when you're fat adapted, and you train this way, you simultaneously build your metabolic capacity, which builds your ability to burn fat at both higher intensities, but also greater rates.
Yes.
And that'll lead us to, this is what's possible. So the reason, like I say, the audience needs to go back to what I was saying about what if the assumptions are based on this modern human who has a diet and lifestyle, relatively sedentary. Even people who train are relatively sedentary, unless you're training for an Ironman or an ultra. There's a lot of sedentary time, right?
Yeah.
So we're going back to that. What if it's based on a flawed thing, not our evolutionary thing?
Correct.
So when you're looking at what, Alan Aragon or Stacy Sims or Jason Koop or Ironman U, the people at Ironman U are talking about, it's based on the body of work up through the FASTER study. And this is one of the key studies. There's several studies that are pretty much the same. And before the FASTER study came out, the absolute ceiling of fat oxidation was 1 gram a minute. This is the data plot. Okay. So this is why all these athletes say you need carbs. All these experts say you need carbs, is because they're basing it on this body of science. Then I could cite there's a whole bunch of studies, but they all suggested that the absolute ceiling for fat oxidation was 1 gram a minute.
Hmm.
And more so to the point, most athletes actually only burn half a gram or less. See, you can see from the
Yeah.
data plot, there's only a couple of people, there's only one person that approached one data point that got to 1 gram a minute at peak fat oxidation. You guys fluttering up around, 0.9, but most people are down here in this 0.5 or less. Okay. Faster study in 2015 changed all that. So the fat adapted athletes, they had a mean of 1.54 and a peak of 1.78. That was John Rutherford, who I just interviewed. Anyway, and I think, and then here's the high carb guys. They're 0.67. By the conventional body of science, they're good fat burners, but they're right in that, they're at the top of that main grouping of data points, right? So you can see that the high carb diet that these athletes were doing aligns with the body of science.
Mm-hmm.
Okay. Right. Okay. So,
Yeah.
and then these two data points, I'm pretty sure, I'm 95% sure that these two data points are with the two low carb guys who are straight keto, because 10 out of the 12 were people I actually personally trained. I personally got them
Mm-hmm.
started. Ben Greenfield, John Rutherford, Dan Lentz, Zach Bitter, all well-known names. I got them started on their fat adaptation journey, and they were doing OFM and VESPA during that time. Now, during the
Yeah.
data collection, they did straight keto, but to get that fat oxidation capacity, you can't do straight keto. And these data points, assuming they are the two straight keto guys, that shows it, because everybody who's doing real sports knows that there's limitations in performance to keto. Okay. It's like the high carb people won't talk about the unintended consequences of consuming all that sugar. The low carb guys talk about all the health advantages and metabolic advantages, but they don't want to talk about the fact that you can go all day, you just can't go hard. And oddly enough, that impairs you from achieving what I would call your potential in terms of health and performance. So we knew there was more out there. Conversations I had with the athletes who got tested, it's like, I wish we could have used VESPA. I wish we could have used strategic carbs. And so a couple of years ago, we did some testing with some of our athletes, and I got two athletes that all the athletes are in this level. They can go a gram and a quarter to a gram and a half all day long. But two of the athletes, and this is one of them, I'm cherry picking the data. But it shows the potential. Okay, I'm not a scientist. I'm cherry picking the data, but this is real data. It's not made up. It's not manipulated. People can go to the Vespa Power site and see the raw data. I mean, we're not trying to hide anything. But here's the test on a treadmill with a metabolic cart. Immediately upon starting, they're above 1 gram a minute, and that's just at a walking pace, right? Setting up the machine and getting it going. You do metabolic tests, you know how it goes. So, and as soon as and this is in the initial two jumps, but as soon as we start doing more of a running pace, right, they jump up to over 1.5 grams a minute. And they can go, as you can see here, they can go all day long at 1.5 grams a minute. Okay. And they
Yeah.
can even sustain over 2 grams a minute for 20 minutes. That's unheard
Mm-hmm.
of. I've got Jeff Browning and Peter Mortimer who live in Flagstaff, so that living at 7,000 feet is a big tool, right? It's just like using the Vespa, restricting your carbs, bringing the carbs in strategically, training with HIIT, tempo, long runs.
Mm-hmm.
It's one of those tools. But they're able to sustain over 2 grams a minute for 20 minutes. And that's very high level work. It's not ultra endurance racing level. This is super threshold. Like here would be what their race pace is. Now, to a point, like I said about the bridge fuel, you can see these little blips, right? Every time they change pace every 4 minutes, there's a little blip of glucose, right? So every time
Yes.
that, there was that extra energy demand, well, the glucose filled that need immediately. And then all of a sudden the fat burning, the liver adjusted to titrate in more fat burning.
So you're saying there's carbohydrates are used first, as people are saying my main question today. Then you burn fat, but just the dose is what's conflicting, I think, of
Well,
how
it's
they're burning fat so well here.
okay. We should be burning fat at our resting metabolic rate. I've got
Yes.
one guy we tested. He was the gal who was doing the metabolic testing on the cart. She'd never seen this before. She said
Mm-hmm.
that 70% fat oxidation and a resting metabolic rate was considered excellent for an athlete. 70% fat, 30% carbs. Jesse was 100% fat, right? He was burning
Yeah.
fat at that. So what I was saying is when you change, you should be burning fat at low aerobic levels, just like this suggests. As soon as you increase the energy demand, like here, when he makes the jump up, a bigger jump in terms of the
Speed.
pace he was doing, there's the glucose making that little filling that gap. Now he's already warmed up, so he's got all his pathways ramped up. But if you're going from sedentary to active, you're going to have this blip. And this is why I'll stop sharing now. This is why I recommend doing a long, slow warm up. So even for
Mm-hmm.
your resistance, you should be doing your cardio with a long, slow warm up before, because you want to signal to your body that greater energy demand, to signal to get those internal energy pathways
Yeah.
going and dilate your cardiovasculature.
Mm.
Because that's what your cardiovasculature, those pipes contract and grow depending on that energy demand. And so the plasma, the blood, what happens is when it grows, you need more fluid. And this is why hydration is so important for fat adaptation. Your interstitial fluid, which is the fluid between your cells, that gets migrated into your cardiovasculature to increase the plasma volume.
Got it.
Okay.
Okay.
And so
So,
that,
but
yep.
keep going. I'm just going to share this screen to look at what I look at when I'm testing someone. So you're saying, not to interrupt you, but just one visual, when I do the raw data of a test, this is the gold is the fat, but how we do a warm up before this, and then I started warming them up, but just how some people metabolize fat differently and how this can identify if they need more time to improve their fat oxidation when they shift to burning carbs pretty early on. So again, test and not guess, but just kind of going into your examples of people that are extremely well fat oxidized or at fat adapted and burning fat high intensities. But then the most people I find their zone two is pretty low and they start to shift early on the metabolic crossover point because they're doing too much high end training. As you're saying, you need a longer warm up and staying more zone two training for some people, where others need more time up here. So,
Yeah. I like to see people push out. What we've seen work well is the 30-minute warm up, because what we're seeing in my data with athletes who are fat adapted is 32 to 36 minutes to where they hit what I call the switch. And
yeah,
that's where everything's ramped up and they can burn fat, and you can feel it on an intuitive relative perceived effort that when you
exactly.
hit that switch, it's like, oh, I can go all day now.
Yeah.
So that's the key. And then there's something to the long duration workouts that changes the physiology, so the fat flow is really just there. So you can increase the rate and the intensity, but to do that, the triggers are the HIIT training, the resistance training, the tempo training. Those are the adaptive signals that say you can get up, but just with the long zone two or less, you end up increasing that oxidation rate and at a higher intensity level. But if you never push your intensity, you can increase your rate, but you're just never going to go anywhere. And you need to reach that. You need to build metabolic capacity. I mean,
So you do
organisms
that.
thrive with adaptation.
So you're saying to build that, you need both. You need the intervals and you need the
Absolutely.
base. Yeah.
Yep. Yep.
And then how much time you need in each one is where we need to personalize it, right?
Yes and no. We're all same, we're all different, but we do a lot of stuff. I'll share a key. Once you're in this, going down this road of fat adaptation, when we do intervals, we do relatively short, super high intensity intervals, but
Yes.
when you hit that all out interval, no matter what you're doing, whether it's rowing, running, cycling, it's a relatively short interval with a big recovery interval.
Yeah.
Because when you're fat adapted, you're not producing the lactate that you have to teach your body to tolerate. They always talk about getting your lactate tolerance up. Well, why not just reduce the lactate? And as you saw with those diagrams I showed you, if you can make that fundamental shift from, say, 0.5 gram of fat oxidation to 1.5 grams, well, when you do the math on the calorie needs, it changes the whole paradigm, right? In terms of fueling. So you don't have that oxidative stress. And it's like with all the athletes, and you know this from your own experience, when you become fat adapted, and especially if you're using the VESPA, the recovery is unreal. Okay. And
Yeah.
here's something key for the audience to understand. This is another paradigm shift. The recovery, the faster recovery, has very, very, very little to do with actually recovering. It's because you have prevented the cellular mitochondrial damage in the first place that you need to recover from.
How do you prevent it? Just say that again. How do you
You
prevent?
stay in beta oxidation. You
Mhm.
stay aerobic, and you prevent all that damage you need to recover from. And this is why people notice the recovery thing, is that fundamental shift to greater fat oxidation provides that prevention of cellular and mitochondrial damage. And I talk about both. It's not just the mitochondria, it's also the cell walls, because there was a study in 2012 called the Western States study, and this led to the FASTER study, but they were looking at cell wall fatty acid compositional changes during the Western States, and they saw that these kind of exercise events create massive amounts of oxidative stress, but that the fat adapted athletes just boom, bounced right back because their fat metabolism was preventing that damage and helping them to recover.
Along with the right nutrition and recovery too, like what they're
Right,
eating
that's it. But it's still,
and how they train.
it's like I say, it's not, it's got very little to do with the recovery protocols, because you haven't done the damage.
Yeah, you didn't need as much. Okay, so because I know we're always short on time I wanted to focus more today on VESPA. Now we have 15 minutes left. What is VESPA? Again, we have lots of videos we've done over the last 10 years. It's Peter.
Yeah.
But just if you're newer and not sure VESPA, I handed up samples at our podcast, North San Diego athlete meetup I had last week, and trying to explain to people this, I thought, well, I'll just have Peter do a new video, explain what is the purpose of VESPA, when do we use it, why do we use it, kind of give us a rundown, and we'll give
Okay,
people
let's
a
start.
link.
Let's start with how VESPA was discovered. It's an accidental discovery of nature, like penicillin or ivermectin, or all these things. A lot of really big scientific breakthroughs were accidental, and this is an accidental discovery of nature. That's nothing to play.
Yeah.
But anyway, it was discovered by a couple of Japanese entomologists who were studying the murder hornets, the giant Asian wasp, commonly known as the murder hornets. And they found that these hornets fly 60 to 100 kilometers a day, and they're apex predators, so they kill stuff. So they violently kill stuff, and then they masticate it into a food ball, and then they take that food ball, which weighs a third of their weight, back to the colony to feed to the larva. And the larva gives it this naturally occurring peptide in exchange for the food. It's called it's a symbiotic relationship between two life stages. So the larva gives it this peptide in exchange for the food. It's called trophallaxis. Well, that peptide is what triggers the wasp to be able to access all the fat that's stored in the thorax. So bees, ants, wasps, termites all have that back part is called the thorax, and it's full of fatty acids because you can store fat really well and stably. And so it allowed it to do these amazing things. So they're like, wow, this is incredible. Okay. And then they hypothesized that because animal cells are remarkably similar across species in terms of cellular function, they hypothesized it would do this in other animals. So they tested on rats and mice swimming to exhaustion. Sure enough, they did. And then they tested on humans. So that's the story. It's what makes the murder hornets the murder hornets. So they have to perform. So what it is it's a naturally occurring peptide we literally get from the hornets through a proprietary process. And this peptide does the same thing mainly in your liver to trigger greater fat metabolism. And that includes ketosis and even gluconeogenesis from liver fat if the metabolic demand is such that you need higher end fuel like ketones for high end aerobic and then glucose for high end aerobic / anaerobic pushes, right? Because glucose is the only fuel substrate you can burn, you can metabolize for energy at supra aerobic levels.
Mm-hmm.
So it's upregulating your liver's fat metabolism to meet that metabolic need. So for most people, it's increasing fat oxidation, but we've seen people do fasted rise, and this is in alignment with the faster study where they showed that muscle glycogen was replaced in these low carb diet people who weren't taking in any carbs, but they had all this glycogen stores in the muscle biopsies after. So before that happens, before that glycogen gets stored, what we've seen is people who monitor their blood sugar, they'll do a ride or a run, and then for the last 20 or 30 minutes, they'll put the hammer down, which increases that metabolic need. And then they'll check their ketone and blood glucose levels after. And very common for most athletes to do fasted rides on VESPA, hammer at the end, and get their blood sugar post-exercise up to 150, 160. One of my athletes who's my age, really fit, he hammered on the bike and he said he got his blood sugar up on a fasted VESPA ride to 270.
Wow.
Yeah. And that's just, the body is remarkable. The liver is a metabolic catalyst. So it'll do what it needs to do to meet those metabolic needs because it's survival, right? So that's what VESPA is. It's a metabolic catalyst. It's a naturally occurring peptide that triggers higher levels of fat metabolism.
Do we need this before we work out? Talk about timing, because I know with a few minutes
Yeah.
left, but
So it's something,
as I was talking about, hold on, before you start, let me interrupt again.
You take it 20 to 40 minutes before
Okay,
a workout. Good. And then if the workout's going longer than 2 hours, you want to start taking it at interval windows of 1.5 to 2.5 hours. So usually I tell people every 2 hours if you're doing extended workouts. And if you're doing endurance exercise where you're going to be going beyond that 2 hour mark and you're going to do some fueling if you want optimal performance. We're not like no sugar, no carb, keto. It's like we want you to use carbs, but use them strategically so they get the maximum benefit with the minimum of the downside impacts. And when we do it that way with the strategic carbs, both in the diet and the fueling, we see that that balance of benefits to detriments, it's like it's more beneficial than detrimental. Whereas if you're doing chronically high sugar all the time, high carb all the time, you get those immediate benefits, but what most people aren't aware of are the long-term downside of having a lot of sugar on a chronic basis. Okay. And
so would this help with the bridging you're talking about? be the start of a workout to help us metabolize fat?
It does, but you still have to get, your body self-regulates,
Mm-hmm.
right? So if you have a low energy demand, even using the Vespa, you'll notice the mental clarity, the focus, you'll be really stable. But if you start to exercise more, it'll help with that getting going. But your body has to dilate cardiovasculature. It has to ramp up those pathways because it's not going to put out it's really smart. It's not going to put out that extra energy if it's not needed.
But the
Right?
question that I hear about that I think people are wondering is, do I need to eat before a workout if it's fat burning? Because I need some glucose in my bloodstream, which is 1 teaspoon. So
Right.
do I need to eat some carbohydrates if I wake up and have my liver glycogen blood glucose levels are lower? Do I need to eat first or have some glucose before I work out so I can metabolize more fat?
It depends on that individual and where they are on their metabolic journey, right? If
Mm-hmm.
they're glucose dependent, carb dependent, they probably should have something. And with Vespa, they can get by on a whole lot less. Like I don't like I have a lot of athletes who are using the Vespa, doing OFM, and they're still, but they can't figure it out. That messaging of, oh, you're going to burn this many calories, so you need to take this many calories in, is really strong, and it makes sense on the intuitive level. And everybody's forgotten, I got thousands of calories on my body. I mean,
Mm-hmm.
and so that message is really hard to get across, that I don't need the calories. I'm fine. A
But
little, if I'm,
the threat of the stress you're putting on your body for more female, they say, over males, that you're activating the kisspeptin peptide you're causing more stress to your thyroid and your cortisol levels up higher. If we have too much stress on board, then we add exercise stress on board. So the whole thing to
yeah,
eat, how
it's
much is Vespa enough?
Vespa, it depends. Once again, it depends on the female. And
Yeah.
we could go into a whole podcast on this because there's a spectrum of femininity, just like there's a spectrum of masculinity. Um, most people are boys and girls, but there's a spectrum on either side. That's one thing. Then it's how carb dependent you are and how stressed you are. And I will say this, and it's really important for the audience to know, chronic stress is as big a deal as too much sugar because it's going to prime your physiology beyond cortisol, which is going to be a sugar burning pathway. Once you get the cortisol up, the adrenaline up, you're burning sugar, baby. And unfortunately, female hardwiring and female hormonal stuff is very sensitive to that because women aren't as strong physically. They don't fight off things. They don't have a lot of testosterone coursing around their veins, and they're there to protect the children. I mean, they have children. They move in this pathway, so they're much more sensitive to these stress triggers. And so it's really important. Like I see this like across species. Like I've got one of the guys I run with, he's a dairyman. And one of the things we talk about is if the cow's stressed, they don't produce milk. And this is well known in human lactation. If the woman's stressed, she doesn't lactate. And so if she's stressed, she's not going to burn fat. So it's really all about what I call the seduction. So women need to be in a comfortable space in today's world because of all the messaging that they have to be a mom, they have to have a career, they have to look good, they have to exercise and do their sport, they have to, all these expectations that are placed on women, because women respond more to that sort of thing than men do. Men, I mean, we're slobs, we're expendable. A lot of times we don't care. I mean, it's
Mhm.
reality. It's just our hardwiring. Um, Women are constantly in a state of stress. And it's like I say, the modern world, this is one of the trade-offs. All this convenience comes with unintended consequences. And it's a lot of these modern technologies are, whether it's your cell phone, non-native EMF, not getting enough sun exposure, it's pinging primitive fight or flight hardware that's setting up our metabolism and physiology to burn sugar in ways it wasn't meant to do. So we got
Mhm.
this chronic stuff. So it's like you can't, you got to just, there's guidance, like people like you, people like me, that can help you, guide you on your way. But that last mile is a very individualized, and you got to take in these details and you got to realize it's okay. It doesn't have to be perfect. it's fungible, but I mean, the expectations placed on them today is you got to be this, you got to be that, and you got to be perfect, and you have to have it. And it's like, it's crazy pants. And so, you know, it's, I think a lot of men are in this mode too, but it's just because the female is hormonally hardwired this way. And that validates what Stacy Sims says. It's her work makes sense in this modern construct because it's real easy. Glucose metabolism is studied like a lot of textbooks, medical textbooks don't talk about beta oxidation. They talk about glucose. Everything's based on glucose metabolism because it's easy to study because you're isolating that one element, energy production, ATP. How many textbooks have you looked at, Debbie, where they talk about the Krebs cycle and all it is talking about is glucose?
Yes, for sure.
Right? They don't talk about free fatty acids. They don't talk about ketones. It's just about glucose. And so we've kind of put in a closet all these natural metabolic pathways we evolved to have. We put them back in the closet for these frontline things. That's a way to put it. I mean, it's like I say, and getting that message to people that they're made to burn fat. And this is the way. They may not be able to burn fat and they may need to have that bowl of oatmeal, right? Or that piece of toast with peanut butter or that banana before right now, but they want to move in that state where they can burn fat. They can go out and take a VESPA, do a fasted run. And to a point, women are fat burning machines. You guys are primed to be, because the whole thing about, it's like I probably said this before, but the woman's biological imperative is to conceive, gestate, childbirth, lactate. That's what keeps the species going because it's not us, right? We're in constant war. Okay. So that's what keeps the species going. And so when you think about it, late gestation, childbirth, lactation, you're not really good at childbirth, at hunting and gathering, right? And you can't depend on the male to be around, right? So when you start looking at the growing a body within you, that's all fat-based burning. Your blood volume increases double when you're at late gestation. Lactation, these are all based on fat-based metabolic pathways. And so women can turn into these amazing fat-burning machines, but they're closely guarding that. And like I say, you got to trick the body into it. And we've got all these variables in today's world that are keeping us from doing that. So, and it goes for men and women, but and women, but it's really, really, women, you don't shrink it and pink it. It's a, it's the physiology is when you add in the hormones and the way a woman's brain is hardwired, there's some differences.
Yeah, and that's why I think it's so important to have personalization in our programs.
Did you get me on that?
Yep. And I think it's important to follow a program that's designed for you based on your metabolic health and your metabolism. And no, it's not one size fits all that we hear on either camps. If it's, Stacy Sims and Huberman and Peter Defty, all these big leaders in our world right now on the podcast.
I'll say it. They're followers. They're following the science. They're looking at the published science. They're maintaining. It's just almost. I'm going off the rails unfiltered for your audience here, but
it's okay.
But a lot of these influencers are playing it safe. When did Peter Defty or Andrew Human talk about the whole COVID mess? They didn't because it wasn't safe.
That's true.
And
but
so
they use the Indio, who's a exercise physiologist that works with the cyclists.
Right.
Indio, that's who they always quote. Yes, that's who they go by.
Right. And I don't. Did Stephanie ever share with you what Ignio did to her at an endurance conference?
No.
She raised her hand. This was when she was working with me closely and I was teaching her all the ropes. She went to an endurance conference where he was speaking and she raised her hand, asked about fat oxidation for performance because it was working for her. He dressed her down in front of everybody. Right. And he's trying to research mitochondria and stuff. And it's just like, I just don't, I get that the demands of pro tour cycling racing are going to demand a lot of carbohydrates, but they're killing people. I mean, most cyclists don't look really good when they're retired. And
Yeah.
um,
Emaciated.
and I've worked with several, including Roman Bardet, and the year I worked with him, he got second at the Tour de France behind what's the Team Sky guy,
Mm.
Chris Froome.
Oh, yeah.
Okay, during his thing, and see, he sent us an email, Dr. Edwards and I, he sent us an email a couple like 20 days into it saying he was feeling good and everything was going well. He wasn't shot by 2.5 weeks into the race. And so the difference there is like Chris Froome was fat adapted, but so was the whole team.
Mm.
You
Yeah.
know, they were employing a lot of strategies like that. So, it that's the thing is like once you're in that, it's like I don't know if do you know who Alan Savory is?
Yeah. I know the name.
He's in the regenerative grassland
Mm.
savannas, regenerative agriculture. You know, he talks about what happens is science gets ensconced in these institutional walls where everybody's just looking at the data and the publications and they cite the other publications and nobody thinks outside the box. And he has a quote. He says, "The finest candle makers could never imagine a light bulb."
They're just focused on building the candle. Mm.
Yeah, yeah, yeah. And it's like what we're doing, you and I, we're not doing anything. I don't consider this like brain surgery or rocket science. All we're doing is getting people back to their native physiology.
Yep. Yeah. So good. Well, I know we're a little over time and I want you to be able to get back to your day. I think people can send in those questions. There's lots of information on your website page. So I'll put this in the show notes, but this page I'll share again on the video version. VESPA frequently asked questions, has so much good information on there. And then I'll put
Yeah,
the link we have for discount code in the show notes.
yeah. Put your discount code in there, um, Debbie. And also, we have another site called ofm.io, which is just think optimize fat metabolism. I optimize
Yeah.
ofm.io, and that's now our content site. So we're because there's so much to this, and because, like I said, you have
Mhm.
to go that last mile of figuring out your variables um, to meet that basic science and research about cells and humans and physiology. It's all the same. It's like how those variables influence all that. We separated the product site from the content site,
Mm.
but
Great.
OFM was developed by through supporting Vespa athletes, and then I just had all these epiphanies that helped us guide athletes to do really well, not just in their performance, but their health.
Yeah.
Um,
Which we should be
and it's
focused
all
on, our
based
future self.
right, our future selves as well as our present selves. I
Yeah.
mean, people were actually performing better, and then they weren't, breaking down, you know, it,
Hmm.
and so it's, it's like that's how it is. So we've
Yeah.
got these two. We didn't, but the problem was because so much of how information is delivered today is delivered in these simple, oversimplified sound bites, and people have, because we're suckers for convenience, we just take those sound bites as if it's true, and then you're kind of like not fitting in the context of your life, and you got to do that work. You got to do
Yes.
that work. And I mean, there's people like you and me out there to help people, guide them on their way, but it's really about individualizing. And so many things out there are commoditized because that's how you scale and that's how you make lots of money. But
Hmm.
at the end of the day, it's not about that. It's
Yeah.
about each individual and empowering individuals, not turning them into a bunch of sheep. And that's a whole
Yes.
nother soapbox to get on.
Yeah.
But once you get fat adapted, you start to think for yourself because you're not having these sugar highs and lows in your brain.
Hmm. Yeah.
Okay.
Well, that's a good place to end. We'll put all the links in the show notes, and I thank you for your time. And we'll find your previous videos we did over the years that we did reviewed the pastor study, and then the study you did 2022. We did a podcast on that too. So put that in
Yeah.
the links for the video. Thank you.
Thanks. Thank you, Debbie.